Right, so thank you for joining. I appreciate your coming to see the talk. So what I'm going to be doing today is basically just giving an overview of the Opaque platform and providing a demonstration, which is based on a use case around consumer data marketing and advertising. And the goal here is to give you a taste about how the platform works, what it does under the hood, and provide you some context around the example use cases we're seeing with customers. So my name is Rishabh, as Rishabh said. I look after the field engineering function at Opaque, and my role fundamentally is to work with customers, understand requirements, and plan and implement deployments, etc., with customers. Opaque, as you may have heard today, provides a platform for secure multi-party collaboration based on big data analytics and AI. And really what it is a capability that allows customers, users to join their data sets securely and protect those data sets, allow them to use them collaboratively, but not to reveal any of their data to each other or to the cloud hosting provider or to Opaque or anybody else. So, okay, straight to that's a bit better. Okay, so to give you some background, the problem that we're trying to solve here is that there is a proliferation of data collection, which is increasing, and this is based on just the quantity of data that's available to companies now, to users. It's the availability of storage, etc. But the problem with this data is much of this data, the granularity of the data means it contains a huge amount of confidential information, right? And companies are struggling to get the value from their data because of the contents of this data. So the goal of Opaque is to allow companies, organizations to utilize that data but still protect that data, which protects them from regulatory risk, from consumer confidence issues and other issues. Okay, so how do we think about releasing the value of data? So organizations across a range of industries suffer from this problem. You know, we think probably traditionally around financial services, healthcare, but actually the problem is pervasive. When we're speaking with prospects, with clients, we see similar situations come up in all areas of data that we use. But especially there's a lot of sensitivity around regulatory environments such as healthcare, finance, and the like. And with regulation like GDPR and what's happening in the United States, that's just increasing. So what is the problem we're trying to solve here? So encryption at rest is a solved problem. It's been a solved problem for a long time. You can encrypt your data, you can store it on-premise, you can store it in the cloud, and you can encrypt it using well-understood military-grade encryption, AES, etc., and you can be confident about the relative security of that data. Encryption in transit also is a well-solved problem. It used to be that SSL was used selectively for certain applications, but now it's pretty much pervasive. So pretty much every communication flow that occurs is encrypted with TLS, and that enables protection of data while it's in transit between different locations. But the problem remains that as soon as you try and use that data, that's when the data becomes exposed, right? And this is when it becomes exposed to various threats, which could be malicious insiders, it could be hosting providers who look after infrastructure where you're using your data, it could be malware, and that malware can even be highly privileged malware that has access to the system kernel, rootkits, these type of things. So this is one of the biggest risks, is that data, no matter how sensitive, becomes exposed when you try and use it. And this is the problem that organizations are facing when they're trying to get value out of that data. And what Opaque does is it solves that last piece of the picture. And in fact, the concept of confidential computing is really about solving that last piece of the picture. And it means that you can even have that data encrypted while it's in use, while it's in memory, while it's being processed, while you're running queries against it. If you're running ML workloads, while you're running inference against it, you can protect that data. And Opaque provides a platform that enables that to happen. Okay, so what I'm going to do today is I'm going to do a demo based on a use case that we've been working with customers and partners on. And this is specifically around advertising technology, marketing and retail data. So in this kind of fictitious scenario, we have a company called Sporty Bar, and Sporty Bar are an online nutrition bar retailer. They manufacture nutrition bars and they sell them online. And what Sporty Bar want to do is they want to move into retail locations. They want to understand how their users or their customers behave when in retail. They want to understand where they're shopping, what competitive products they're buying, and understand generally their behavior. Now, this is where sales solutions enter the picture, and sales solutions are a data provider that have a huge amount of information about retail use, what people are doing in retail locations, what they're buying, and that data extends beyond nutrition bars to all sorts of things, right? They have a huge amount of data on retail behavior. So the two of them can gain benefit from collaborating. Sporty Bar want to be able to buy and use the data that Sales Solutions offer so they can understand what their customers are doing. And similarly, Sales Solution obviously want to provide that as a service, and they want to sell that access to Sporty Bar. But both of these companies are very protective about their data for different reasons, right? So Sales Solutions, their data, first of all, it contains a lot of PII information, and also it's their intellectual property, right? They don't want to release that data. They want to be able to sell use of that data without selling the data itself. Sporty Bar, on the other hand, do not want to release information about their customers. Again, they have a responsibility to protect that data for their customers at PII. They have information, for example, credit cards, addresses, details of date of birth, all sorts of private information about their customers, and they want to make sure that's protected. So the question is, how do you enable these two parties to collaborate and on that data, but without exposing their data to each other? And again, this is where Confidential Compute and Opaque's platform provides a solution. It allows them to collaborate securely on that data without revealing any of that PII or that commercially sensitive data to each other. Okay, so how does this kind of look in practice? So what happens is Opaque provide the clean room capability to deliver this. The data consumer, in this case Sporty Bar, can put their data in. The data provider, in this case Sales Solution, can put their data in. They can securely join that data using big data analytics, data queries, to understand how their data sets overlap with each other, to understand how they match that data between the two. And then they can run analytics and even ML workloads potentially across that data to gain insights, but without ever revealing the contents of that data to each other. So it allows them to query, to share, to provide access to data, but without handing over the data and retaining their data sovereignty. And Opaque provides the capabilities to enforce policies, to precisely state exactly how each party can use their data and how their data can be used by the other parties. And those policies include input policies around the data that's put into the clean room, columns, match base data on rows, but it also includes strict policies on the scripts that can be run, the queries that can be run, and how the data can be used by each party. And in addition, it's also a common use case that sometimes the two parties actually do not have data in common, and you even have other parties involved in the collaboration that provide data resolution. So for example, in another scenario, the data consumer, it could actually be an advertiser, for example, and they have IP address information about a party, and that's all they have. They want to work with another party that has an advertiser who wants to leverage that data, and they have email address or other private data, and the two don't have any common data. And it's quite possible for a third-party data resolution provider to provide a join so that the two parties can conditionally join their data, again, without anybody in the collaboration sharing that data with each other or releasing information about the row-level information that's sensitive. Okay, so fundamentally the platform allows collaboration between many parties. It can be 2, it can be 3, it can be 20. Really, each of those parties can play different roles in the collaboration. They may be facilitators, they may consume data, they may provide data, or equally it can be a kind of an equal partnership where two parties are collaborating equally and joining and sharing their data. This is true for organizations where they have trouble sharing data within the organization between different parts of the organization due to regulatory constraints, Chinese walls, these type of things. Equally, it can be parties that external organizations that want to share data, and they can't do that because of the commercially sensitive nature of the data and other requirements, right? So we can ensure that these parties can share and collaborate without ever exposing their data to each other. Okay, so how does this kind of work as an example? So in this case, the parties, the data resolution provider and the data providers, they put their data encrypted into the data clean room. So the data is encrypted before it's entered into the clean room. so it's never visible at any point, at rest or in transit. The daily consumer can then construct a query. That query can be checked against policies to understand if they're complying with the requirements around data use. The job can be run, and assuming it complies with those policies, and the results can be returned to the consumer. And equally, it could be an ML workload where an inference is done against a model that's secured in the enclave. And again, the same thing applies. A policy can be applied. The data can be checked, or the query, or rather the inference can be checked against policy, and if it meets compliance requirements, the results can be returned. Okay, so I'm going to just quickly now give a demo on the product so you can actually see this in action. So give me 1 second just to... Okay, so this is, if I pull up both the parties here. So what I have here is two parties. We have Alice at Sales Solutions, and we have Bob at Sporty Bar, and they want to perform this collaboration. So both of them, as I've said, can upload their data, and this data is encrypted. And in fact, if we go and have a look at, on the storage and see how this looks, we can actually see, so here, for example, here is the data itself, and all data on storage is encrypted and unreadable. Okay, so that data is never exposed while it's at rest in storage. What can happen then is a query can be proposed. For example, this first query is what we call a match testing query. So what the query seeks to do is it just joins the two data sets, and it finds out how many matching records are there between the two data sets. So the goal here is to find out what the value is of a collaboration between Sporty Bar and Sales Solution. Now this has to go through an approval process, and fundamentally this is a SQL query. It's wrapped here in a script, a Scala script, and the reason for that is that the platform is built using Apache Spark for scalability, so it's a highly scalable platform, distributed platform, which enables very large-scale implementations, data, and queries. And once that query is constructed, it can be submitted for review, and then other members of the consortium then effectively can then go ahead and they can review that query, and they can choose to either approve it or they can choose to deny it as appropriate. So here we go. So I can go ahead and review the query, make sure I'm content with its use, and I can go ahead and approve that query. And then once that's done, now Alice is able to run that job. And what's happening during this process now is the data, the secure encrypted data is being collected from storage. It's being pulled into a trusted execution environment, a secure enclave, where the data, where the query is executed. And what happens, that job's going to probably take about 45 seconds or a minute to run or so. But what happens there is that ultimately the results of that query will produce, and here's one that I ran earlier, will produce some results there, and it tells us that of the two data sets, there's about 34,000 matching records. And the important thing here is that the results of the query here reveal absolutely nothing about the contents of the data, any individual row data, PII, anything like this. It simply tells the two parties how much data they have in common without revealing anything deeper about the data. Okay, and there we go, that job's finished. So what then can be done is, and because this is based on SQL or Scala, you can really achieve anything here you want to, that you can articulate in a query. So for example, here we have a query, and the objective of this query is a more complex query with subqueries and joins, et cetera, but the goal of this query now is to find out more information for Sporty Bar about their customers' behavior. And what this really does, again, if I show you the results, what this is really revealing here is, again, without revealing any specific details about any of the individuals, about their PII, even their names, we don't know which of the records are matching. Neither party knows which of their customers exist in the other data set. But what it does reveal is information about, for example, the market share in retail locations that Sales Solution have, like what are the top sports bars or nutrition bars and what is their market share. But crucially as well, so this first number is the general market share in the data set. But the second and third rows here actually reveal really useful information to Sporty Bar. What they say is that, for customers of Sporty Bar who buy their products online, this is their behavior in retail locations, right? We can, in fact, we can see here that, for example, if you like, the base market share for Power Bar is about 8.8%, but actually for Sporty Bar customers, about 25.7% of their customers buy Power Bar when they go into a retail location. Okay, so this is a great insight because it tells Sporty Bar that that their users have a high propensity to buy this competitive product, right? And again, it does this without ever revealing the underlying data to each party and ensuring that neither party is exposed to any regulatory risk and they've never had to hand their data over to each party. They don't have to trust the other party. All of the controls are applied technically and cryptographically to ensure their data security. And also what we see here is the third result in this query tells us that Sporty Bar has a set of their most engaged customers. And these are customers that spend the most money, they buy the products most often, they maybe engage in social media campaigns or whatever that might be. And they can see that, again, those customers are more likely to buy Power Bar, but also that those customers, again, unlike their regular customer base, are more likely to buy Cliff Bars. So, again, by doing this, Sales Solutions do not learn anything about the individual customers. There's nothing that they're collecting that allows them to leverage the Sporty Bar data set, if that makes sense. And equally, like I say, you can extend this to any query that you can articulate. So, for example, here we have another query which is run. And again, this reveals more information about the retail location behavior of their customers. So this allows Sporty Bar to understand where their customers are shopping. And again, we see that Walmart appear to have the lion's share of that nutrition bar market. But interestingly, Walgreens and CVS here, Sporty Bar customers are more likely to go and buy products there than the general market share. So it may well be that these retailers are easier to work with than Walmart, and Sporty Bar can identify, okay, these are the places that we should probably go and investigate first once we want to release our product to market. And again, you could formulate even more complex. You could look at a comparison of their competitors and where their competitors are selling products. You can really do anything. And again, any query you can articulate that gets approved by the consortium can be run. But the important thing is that the data sovereignty is always maintained by the data owner. The data is never handed over, and that can be revoked at any time. And all of the access to data is constrained by policy, which the data owners control. Okay, so I'm going to pause there for a second. So does anybody have any questions about that? Yes. Yeah, they do. Okay, so in order to construct the query, you'll need to understand the schema you're working with. And what the product does allow you to do is it allows you to understand the schema, obviously without really revealing the data. You can understand the schema. That data can also be shared, obviously, between the collaborating parties to understand not only the columns, the data types, but potentially the purpose and use of those fields as well for constructing the query. And sorry, just in case, I'll just articulate what the question was in case I didn't cover that. So the question was, do the parties need to understand each other's schema? Any other questions? Yes.
I have a similar question around the schema, like knowledge of the schema. So let's say in order to do the matching, there has to be some sort of like fuzziness to the matching.
Yes, yes.
Like maybe some sort of like proximity on the machine and that sort of thing. What are some ways in which the parties can go about using some sort of like quality control on the matched results to understand whether it's meeting some level of acceptability?
Yep.
Because like when you're doing the blind computation, you may not have that insight, right? Or you then know that you can rely on the results.
Yeah, okay. So the question was really around understanding the schema, especially when performing fuzzy joins, which are basically distance-based joins, a join where the data is not a perfect match, for example. And this would be a common use case for names or addresses where they can be represented as street or st dot, etc. So one of the, just before I answer your question, one of the benefits of using this kind of technology as opposed to some of the traditional approaches of using hashing or something like this is when you hash data, you need to have an exact match, or the hash is, the nature of hash algorithms means that even a very minor difference in the data results in a vastly different hash, so you can't join the data. Because you don't need to hash the data, because the data is encrypted at all times, it does mean that the data can be treated as if it's unencrypted effectively in terms of the query, right? And that what allows you to do is it allows you to perform more complex joins, like distance-based joins. For example, you could say, that the two have to match to a certain number of positions, right? Something like this. And really, how close is, what you can do to try and answer your question is you could potentially run a match based on a precise match. You could run another query based on a distance-based match and try and find out, your match conditions. I think given that you don't have necessarily visibility of the data that the other party is providing, obviously you need to be considerate about how you do those distance-based matches to ensure that you're getting a high-quality response. But it does allow you to construct a join, based on any number of distance-based operations, so you can get kind of fuzzy matching in your data operations. But I think probably some kind of collaboration around the way the data is structured with your collaborating partners would be good in that sense, right? To understand how they're formatting their data. Okay, thank you. It's a good question. Thank you.
Maybe about the question, given that the parties have to know or agree on the schema, you're going to have to, you have within notion of like vectorization and, nearest neighbor kind of thing, or anything that can be vectorized?
Yeah, so just to make sure I understand the question. So I think the question is, about understanding the schema is, how do you go about agreeing with your collaborating parties on the nature or the structure of the data to make sure that the joins or whatever work correctly? Is that kind of... Yeah. So I think, yes. So what the product allows you to do is understand the schema in terms of the data types, etc. What it, obviously, because it doesn't reveal the data, what it doesn't reveal to you is the structure of the data. So that obviously that's something, when you're collaborating, you need to reach an agreement on, some agreement about the data's, how the data is going to be structured, and standardization, if you like, on the data. I think that when you're collaborating with other parties, probably there's some kind of sanitization that happens before the data is put into the clean room, right? Like an agreed standard around how data should be structured, so that you're at least, the data is formatted in a similar way that you can perform those operations. Does that answer the question?
Let's take it offline.
Okay. We
Suppose one other thing you could do is maybe like before you deal with the production data, you can maybe do some tests with some either sample or synthetic data that is
Yep.
in the same format as what will really go in, and then use that to maybe do some quality control on the match quality.
Yeah.
And I'm assuming you're satisfied with that, then you have confidence that when you bring in the production data, it will be good in some
Yeah, exactly. So, so the commentary there was, I think, just gaining a common understanding with your collaborating parties about the structure of the data, and you could use, for example, some synthetic or created data that at least you can understand how the data is formatted before the collaboration happens. Yeah. Okay. Yes.
So with it collaborate with somebody, how do I know if they have really accurate data and how much they only brought on some information and this other one completely doesn't have much, but now much information like
Yeah. So, yeah, okay, so to answer that question, I think Opaque provides a platform that allows the collaboration to happen. Obviously, the data quality and what goes into the collaboration is going to be the responsibility of the parties, because, Opaque and, in fact, the parties don't have visibility of each other's data. But that said, I think the example I showed where you can perform a query to find out how many are joining, you can perform any number of matches. Like you could run a query to say, okay, how many common parties do we have in our data set, right, from the total amount? You could say, for example, okay, in addition to how many parties are joined, how many of those joined records contain column X, right? You could write a query to say, okay, there's 34,000 joined entries, of which only 5,000 contain a phone number, for example, right? So you can construct a query to understand the value of the data before you enter into collaboration. Because obviously, even if you've got 34,000 joined entries, if none of them contain a phone number and you want a phone number, then there's not going to be, you're not going to get the value from that. So again, I think that's part of probably the initial phase of the collaboration. You might issue a query which basically just says, I want to level set the structure of the data, the contents of the data, how much value am I going to get from the data? And again, you can do that without revealing the row-specific details. You can just, you can take counts, etc. those type of aggregates to understand what the percentage hit rate is, those type of things. Is that okay? Yes. Yep. Yep. Okay, so I'm going to try and summarize that. So I think, is the question about if you've got parties collaborating, but one of the parties doesn't have the deep understanding to understand? Yeah, okay. So just first of all, this is, and you mentioned about ML training, etc. This specific example is more of a big data analytics. It's a query, but it's true equally that you could run ML training or this type of thing in here. So I think that there's a couple of options there. So first of all, the parties are ultimately going to be responsible for understanding how their data is used. However, it's also quite, it's quite reasonable that you could have a, in this case, maybe Sales Solutions have a lot of experience with dealing with these kind of retailers, and they provide some contractual assurances around the way that the query is going to be written. But ultimately, if you don't have the expertise to understand the query or the model or something, then, there's a risk that the other party is doing something you're not expecting. But what I can say is that, assuming that you trust them, at least because the control is applied cryptographically, right? Once you understand that what the query or the model is doing, you can be sure that it's going to always behave in the same way, right? And you're going to get the results. So there can't be any malicious intent later about that. But I think in some cases we have some customers where we kind of, we work. By the way, this is all drivable via API. So it's quite possible, and we have some customers we're working with on a kind of a no-code interface where rather than needing the expertise to drive, to write a query, you can just provide some variables and use an interface where the user just selects some variables and doesn't have to actually construct a query. Yeah. Yeah. Yeah, correct. I mean, the product provides you all the capabilities to understand and enforce a policy. Obviously, the mechanics of how the policy is understood and how it, and how it's implemented is down to the collaborators. But okay, I'm conscious I'm out of time. So, if anybody else has any questions, I know you said it's about taking it offline. I'll be at the back of the room. I'm happy to talk to you. And thank you very much for your time.